I'm Jubellaria, and I'm here to answer all the activities in Chapter 9. Chapter 9 Transport Layer. In this chapter, the data networks in the internet support the human network by supplying reliable communication between people. The definition of transport layer, or what is the transport layer? The transport layer is the layer in the Open System Interconnection (OSI) model responsible for end-to-end communication over a network. It provides logical communication between application process running on different hosts within a layered architecture of protocols and other components. The transport layer is also responsible for management of error connection, providing quality and reliability to end user. This layer connected data packets or messages over a network, and this is the network computers component that allows multiplexing. So the process described in the OSI transport layer accept data from application layer. And when thinking about the transport layer, think of a shipping department preparing a single order or multiple package for delivery. So in this activity, we need to answer all the activities in chapter 9. So the first activity in chapter 9 is TCP, UDP, or both. So the instruction is drag the application layer protocol to its transport layer delivery method, TCP, UDP, or both. So we need to drag all the layer protocol to its transport layer delivery method to TCP, UDP, or both. So in this activity, we need to drag all of this, like the HTTP. The HTTP is in TCP, the Telnet, the FFTP, the SMTP, and the UDP. The UDP is, I think, VOLP, the IPTV, the TFTP, and the DHCP. And for the both is the SNMP and DNS. So that's the corresponding term in the TCP, UDP, or both. Um, when we say TCP, um, the TCP is the abbreviation of Transmission Control Protocol that pronounced as separate letters. TCP is one of the main protocols in TCP IP network, whereas the IP protocol deals only with packets. TCP enables two hosts to establish a connection and exchange extreme of data. The UDP or User Datagram Protocol is an alternative communication protocol to Transmission Control Protocol (TCP), used primarily for establishing low latency and loss tolerating connections between applications on the internet. So the let's check if the layer protocol is correct on TCP, UDP, or both. So you have successfully matched the application layer protocols to this transmission layer delivery methods. So the next activity is activity part 1, TCP connection termination process. So instruction: drag each descriptor to its appropriate place in the image to illustrate the three-way handshake of TCP establishment session. So this is the PCA and the PCB, the send CYN and the receive. So let's drag the ACK, CYCK, and CYN to this corresponder whether it's receive or send. Send CYN is receive CYN. The send CYNCK ACK is receive again CYN ACK. The ACK receive I send is receive again the ACK. So in data network telecommunications, the computer passes an acknowledgement. ACK is a signal is passed between communicating process computers or devices to signify acknowledgement or receipt of message as part of communication protocol. The SYN is a TCP packet sent to another computer requesting that a connection be established between them. If the CYN is received by the second machine and CYN or /ACK is sent back to the address request by the CYN, the TCP packet sent to another computer requesting that connection be established between them. If the CYN is received by second machine and CYN ACK is sent back to the address request by the CYN. Last, if the original computer received CYN/ACK, a final ACK is sent. So let's check if the TCP connection and termination process are correct. So you have successfully illustrated the three-way handshake requirements of TCP establishment session. So the next activity is four-step process of TCP termination session. So drag each descriptor to its appropriate place in the image to illustrate the four-step process of TCP termination session. So the PCA and PCB. The PCA send FIN, it receive FIN. When ACK TCB send ECK, it receive ACK. When the PCB send FIN, it will receive FIN. And when the PCA send ACK, it receive ACK. So let's check if the TCP connection and termination process are correct. So you have successfully illustrated the first step process of a TCP termination session. So the next activity, chapter 9, is TCP and UDP characteristic. The instruction drag each characteristic to its TCP or UDP delivery method. So these are the characteristics of TCP and UDP. So we need to identify a TCP and UDP. So the first one is less overhead. So I think it is UDP. The connection less. I think it UDP. The fast transmission requirements. I think it is UDP again. The sequence message segment. I think it's TCP. The no acknowledgement or receipt. I think it is UDP. The no order delivery. I think it's UDP. And the guaranteed delivery is on TCP because the UDP is full the full all the characteristics in UDP. The flow control is TCP. The session establishment is TCP, and the last is order delivery. So the, so let's check if the characteristics are corresponded to its delivery method. So you have successfully matched each characteristic to TCP or UDP delivery method. So this is the TCP and UDP. So the our TCP, the sequence message segment, the guaranteed delivery, the flow control, the session establishment, the order delivery, and these are the UDP less overhead, connection less, fast transmission, no acknowledgement or receipt, and no order delivery. So that's all guys. I hope you learned from those activities I've answered in chapter 9.